Welcome to Module 4, Lesson 10, Simple Interest. And yes, I have underlined simple here because there's a very important distinction. In the future, you'll be learning about something called compound interest, which is much more beneficial to you and I when we're trying to save money and have our money make money for us in a bank or some sort of investment. So in this case, we're looking at simple interest. Pretty straightforward, but still something that kids do tend to trip up on. Okay, so we will be using the following simple interest formulas, okay, or formula. And you'll see this on the next page as well, and you'll probably see it there in your binder. And it looks like this. Capital I equals capital P, RT. Okay, and these very simply stand for interest equals principal. Okay, and we'll talk about what that principal is. It's actually your investment, the money you've put into the bank or put somewhere else. Okay, so and then that's the rate. That's your interest rate. Okay. Right now, interest rates in banks are pretty low. You don't make a lot of money on a regular savings account or certificate of deposit like you would have when I was your age. My mom and dad put money in what was called a CD or a certificate of deposit, and that made like 14% interest. Okay, it was quite high. That's an annual interest rate. Right now, those types of investments are, in the single digits. Boy, I can't believe they're even out of 2 or 3%. Okay, and then the T here in our formula equals time. Okay, and we'll see later on in this lesson how this interest rate period, for example, annual or per year, and time need to match up when we are doing putting this formula to use. Okay. Okay, so here we are at, and you can see here again is what you have in your binder. Okay, and it just kind of gives you just what I did, the definitions. Okay, now this one is the last thing I had mentioned, the last point I had made, which is very important. So R and T, which is rate and time, must be compatible. Okay, must be compatible. For example, if R is an annual interest rate, then T, time, must be written in years, okay? Because there may be, and there's going to be, a problem in this lesson and in your life where you may want to see how much interest was earned or will be earned over 6 months, which is not a full year, okay? But your interest rate is usually always stated in terms of annual rate, okay? Sometimes you'll have semi-annual rate, which means half a year. Okay, you may make 3% each half a year. Okay, semi-annual, but mostly it's going to be annual. Okay, so you'll make a 4% annual rate. That means you'll make 4% on that money per year. Okay, but if you're trying to find out how much money you might make or project how much money you might make in 3 months, then you've got to adjust. And if you're thinking about it right now, you know that 3 months, okay, we could put that in terms of years, would be 3 over 12 because there are 12 months in one whole year, which of course is 1/4 of a year, a quarter of a year, or we could write that as a decimal as 0.25. Okay, and that's what we would use when we plug in T in our formula. Okay, get rid of all that. We're going to see that again later, so don't need to remember that right now. Okay, yeah. So here we go. Example 1, can money grow? Yes, can money grow? Don't we all wish it grew on trees, for example? Okay, but here we go. We're going to look at simple interest now. Okay, so in this first example, Larry invests $100 in a savings plan. Okay, so $100. So right away we're thinking, what is that $100 going? Where is that going to land in our formula? Okay, so we're always thinking that first. Okay. The plan pays 4.5% interest each year. Okay, we can see this annual, it's an annual interest rate, 4.5%. We're going to do something with that 4.5 later on. Okay, and on his account balance as $100. Okay, so that $100, okay, is the same as that $100. Okay, he invested this $100, and that is his account balance. Okay, that's what he has. Right, we're just saying that's all he puts in. He's not going to put any more in, which is a really important point, because all of these examples in this lesson, you have someone putting a certain principal in to an account, and that's it. They don't add any more principal, because, in truth, in real life, that's what we would do. For example, I have a college account for my children, so I put in some money every month. So each month I'm putting money in, so that money can make more money and earn interest, et cetera, et cetera. And I'm sure many of your parents are doing the same. Okay, so the question here is, how much money will Larry earn after 3 years? And then after 5 years. So we have 2 different periods. And again, pretty unrealistic in the sense that you don't just put $100 into a savings plan and then never put any more money in. Okay, and especially 3 and 5 years. Okay, but anyway, we're going to do this because it is simple interest. All right, and we're keeping it simple. But again, it just gets the point across. Okay. All right, so we're looking at how much will he earn in interest. So interest, therefore, is our unknown. Okay, it's the unknown here. So we have I equals P times R times T. Okay, that's our formula. And I being our unknown, and then the P, the principal, is that $100. Okay, the $100 that he invests. That's our P. Now our R, okay, our R is 4.5%. Now something that needs to become just natural for you all is be able to write this 4.5% as a decimal. Okay, if we could start doing that transfer, as you can see, this 4.5% is going to be the same as 0.045, or in this case, that's 45 thousandths. Okay, 0.045. So being able to transfer these percent interest rate into decimals will be very helpful. Okay, and then of course our time period, our T, is 3. Okay, our time period is 3. Now they're compatible. We have a, a time period that's in years, and we have an interest rate that is also annual based on 1 year. Okay, so we're good to go. And very simply, all we do is do some multiplication here. Okay, so 100 times 0.045 times 3 is going to equal $13.50. Okay, and that is pitiful. Okay, and this is why you want to set up a savings plan where you are saving money or putting money into an account regularly, monthly, semi-annually, whatever. You want to actually get money in. It takes money to make money. Okay, it's really good for you guys, especially at this point in your lives, saving up for college, etc. Okay. Now, if we go ahead and so we have that interest, the 3-year interest is $13.50. Now we can go ahead and now we're looking for 5 years. Again, I have my 100, still the same principal. Okay, my interest rate hasn't changed, but the only thing that has changed here is my years. Okay, so I'm looking at 5 years now. Again, just a simple multiplication problem, and that brings us to $22.50. Okay, so this last part here, this part B here, says how can you find the balance of Larry's account at the end of 5 years? Okay, so it's a little bit different now because we're not talking about the interest, but we're talking about the balance of Larry's account, and that has to include both interest and the principal. Okay, the principal that you started off with plus the interest. Okay, so with simple interest, this is simple. Okay, again with other forms of interest, such as compound interest, This is not as simple, but simple interest is simple. All we do is add our 100, which is our principal. That's what we started with, or Larry started with. Add that interest that he earned in those 5 years, which is $22.50. Add those together and you get $122.50. Okay? And that is his balance of his account at the end of 5 years. Okay. All right. So now we're going to look at a like a little chart here. Okay. It's going to show you how we can go ahead and actually I'd love to have you in class. I could actually ask you a couple of questions here too. I'll just show you how this chart works out. And what we're going to do here is we're going to look for some proportional relationship. Yes, we are going to start throwing that vocabulary around again. Proportionality, proportional relationship, etc., etc. Okay, so we're going to throw those out. So we're going to try to look for some relationship here. So you can see down in the left column there, years, and that's our T or time. 1, 2, 3, 4, 5. Okay, so 1 through 5 years, and then the other column there is our interest, or I. That is actually an I, not a P. It looks like a P, but that's an I, interest earned after T years. Okay, so year 1, okay, that equals 100. And again, we're talking about Larry's situation again. 100 times, that's the 4.5% interest, times 1 is 450. Okay, pretty straight, clear. Now, that should be 2. Oh, sorry, that's an I there. Excuse me, these are I's over here. It's not 1. I. Okay. And then again, interest here equals the same, 100, 4.5% interest, 2 years, $9. We go to our third year. The only thing that changes is that we multiply it by 3, get $13.50. And then in year 4, we get $18 even. And then in year 5, we get our $22.50. Okay, $22.50. So let's go ahead and look at these. Look at this table, and let's find some ratios or find some relationships. Okay, so in simple interest terms, $4.50 is earned each year. Okay, so you can see that, and you can see that relationship. From year 1, after 1 year, you earn $4.50. And that, of course, doesn't mean your balance is $4.50, but that's how much you've earned extra on top of your balance, which was $100. Okay? Here's a question now. What relationship do you see between T and the respective interest earned? What is that relationship in terms of a ratio or a proportion? And if you look at year 1, $4.50, 2, $9, 3, $13.50, okay? And what is our constant of proportionality? Remember that term, constant of proportionality, okay? Because you can see that it is proportional, okay? I guess thought I was going to answer that question there, but I guess I didn't. Yeah, in terms of our constant of proportionality is actually 1 and 450. So you can see it right there. Every year you earn 450. 1 times 450 equals 450. 2, I guess I didn't need to do that. 2 times 450 equals 9. 3 times 450 equals $13.50. Okay, so $4.50. Okay, so 1 to 450, or 4.5, we could even say, that is our constant of proportionality. Okay, and that is the relationship between T and respective interest earned. Okay, so we can easily plug in how much interest we will have earned after 10 years. That would be 10 times 450, which would be $45. Okay, So again, we're going to be looking at this, and as you can imagine, we're talking about constant proportionality. We're going to be looking at graphing this, this lesson as well. Okay? And let's go ahead and do that right now. So how might this data look on a graph? Okay, and if we do, and I'd like for you to do this, grab a piece of graph paper if you would. Always good to have practice, practice making graphs. And okay, and I want to ask you some questions here. And again, you can answer them, you know, even though I'm not there to listen. Just be good to, you know, yeah, whatever. Sorry. All right, so how might this data look on a graph? And look right here, what goes here? Okay, what goes on our x-axis? Okay, our x-axis, we are going to put years, okay? And that, that variable, we'd say, is, that's our independent variable. Okay, that's the one that changes, okay? Because they're going to change, we're going to go from year to year, 1 year, 2 years, 3 years, 4 years, 5 years. Okay, so that's our independent variable. Those years go there. And then what is going to go on our x-axis and become our dependent variable? And that, of course, is going to be the interest earned in dollars. Okay, all right, interest earned in dollars. Okay, because these amounts depend on the years, okay? Depend on the years. And for 1 year, and again, we're going to plot these points, okay? So right there. Oop, there we go. I thought I had paused in between, but I guess I hadn't. Okay, so our first point here, right there. Whoopsie. Just get rid of that. Just want to point to it. Okay, so that point right there, that is our constant of proportionality. That is the place where 1 year earns you $4.50. So if we were to actually put coordinates there, that would be 1, 450. Okay, and that's our constant of proportionality. That is where we have one of our independent variables, or 1 year gone by. Okay, our next one here is 2 years. That's 2 and 9.
There is a white Suburban parked in front of the gym.
Let me pause while this is happening. Well, as you can hear, I'm in the classroom finishing this up. So at this point, we are looking at 2 years. Gets us $9 interest. We just put 2.9. Okay. This point, this is 3 years, and at 3 years, we get 13.50. Okay, and here is, of course, 4 and 18. This one here is 5 and 22.5 or 22.50. Okay? We are talking about dollars and cents, so we put the 50 there. Okay? So I just plotted those points, and those points, of course, came from our data set. All right? And if I draw a line through it, that line gives you an idea the way it moves up in a very proportional way. And of course, what does it cross through? It crosses through 0, 0, the point 0, 0. And you remember that was a definition of a proportional relationship, okay? When the line passes through 0, 0, and it moves in a very regular arch up. It's a straight line, okay? And I forgot that should be time over there. All right, so this is a picture of our proportion. So what do some various points mean? Okay, so what do these points mean? So for example, what does that point 0, 0, which the line passes through, what does that actually mean? And again, these are questions we were asked quite a bit in the first module. And of course, if you remember, many of you do remember, that is where 0 time has gone by and 0 interest is earned, of course. Okay, and how about this point right there? 1. Let's take that out of there because we have that there already. 1,450. What does that point mean? And that point, of course, is where 1 year earns 450, and it actually serves as well as our point of proportionality. Oh, what do we call that again? Sorry. Oopsie daisy. Let me go back. Okay. Of course, our constant of proportionality. Yikes! That just like left my brain. Okay. Yeah, that 1/450. Alrighty. So here we go. We have exercise 1. And in exercise 1 here, we are going to find the balance of a savings account at the end of 10 years if the interest each year is 7.5%. And the principal is $500, okay? So we have all our pieces here. We have 10 years. We have 7.5%. We have principal, okay? Now, how this differs, this exercise, and you might see this differs because what we're being asked to find is the balance of a savings account, okay? We're, actually I shouldn't put that yet. Let me just put that back. We are, I want to underline this because we are trying to find the balance of the savings account, okay? We're not trying to find the interest earned. Of course, we'll have to do that first before we can find that balance, but we are answering the question a little bit differently, and it's always good to, to know or to be aware, point out exactly what the problem is looking for, okay? So again, here's our interest formula. And we'll just plug in interest equals 500, which is our principal, times 0.075, which is equivalent to 7.5%, times 10, because that is our time. That's how many years go by. These things match. They correlate because we're talking about a yearly interest term, and we are talking about interest earned each year, okay? So they are compatible, so we can keep it like that, all right? And if we go ahead, we'll do that multiplication, very simple, just 500 times 0.75, or 0.075 times 10, and we get $375, okay? Now that is our interest, okay? What we need to do next, though, is we need to add that interest to the principal, because that balance is always going to be the principal plus the interest earned, okay? And in this case, that's 500 plus 375, which equals $875, okay? $875 would be the balance of this account after 10 years earning that much interest. Okay, so now in example 2, we are going to do something similar, but we're going to be looking at a time other than 1 year, okay? Because it's very convenient to, to look at this simple interest. Again, it's extra super simple when you have an even number of years, okay? 1 year, 2 year, 3 year, 4 year, 5 year, very simple. But sometimes you'll be looking at months, okay? So let's go ahead and take a look at this example 2. And in this example 2, we're going to need to convert. Okay, so knowing your conversions, very, very important. Well, in this case, you're only going to need to convert from months to years, which we're all very familiar with. Okay, so the problem asks this. It says a $1,000 savings bond earns simple interest at the rate of 3% each year. Okay, so we're talking about a yearly interest rate. The interest is paid at the end of every month, okay? And that's going to be important at the end of this problem, okay? The interest is paid at the end of every month. How much interest will the bond have earned after 3 months, okay? And there, hence, the 3 months is the rub. It does not match, it's not compatible to this annual interest rate, okay? They are not compatible in this form, okay? So what we're going to need to do is we're going to need to convert, And converting months to years is a very simple thing, because all you need to do is put how many months you have. You have 3, and that's 3 out of 12, because there are 12 months in a year. Boil that down to 1 over 4, so that means we're talking about a fourth of a year, or a quarter of a year. And what we do with that is then we turn that into a decimal, which makes our lives easier when we use a calculator. Okay? So now that our time, our t, is going to be in the form of a decimal this time. Okay? That's the time. So here we go. Let's go ahead and do it. We have interest equals P times R times T. Now we can just do all the plugging in. So we have interest equals our principal, which is $1,000 savings bond, times the annual interest rate, okay, the interest per year, which is 0.03, which is the same or is equivalent to 3%. Then multiply that by 0.25, which is a fourth or a quarter of a year, which is equal to 3 months, okay? So everything is now compatible. Now it works out, and we do our multiplication, we end up with $7.50, okay, which seems pretty minimal for $1,000 savings bond, but it's probably very true. Okay, those do earn simple interest, which again, like I said, is pretty much a ripoff. Okay, so there you go. Hopefully that looks easy enough for you. I'm sure we'll get lots of practice in the future. All right, here we are now. We are on example 3. Okay, now we are looking at solving for P, R, or T. Okay, we've been solving for I for the most part this entire time. Okay, we've been getting interest because we've known our principal, we've known our interest rate, we've known the time period, but now we are going to have one of those to serve as our variable, our unknown. Okay. So let's start up here with Mrs. Williams. And this problem here, we're going to work backward. Okay, we're going to work backward to get this one. So Mrs. Williams wants to know how long it will take an investment of $450 to earn $200 in interest if the yearly interest rate is, if the yearly interest rate is 6.5%, paid at the end of each year. Okay? Now here's all our pieces. We have an investment of $450. We have our P. We have our principal. We have $200 interest, which is our I, because she's trying to find out how long it will take to earn that much. So she wants that $200 to be a known, and then we know our annual interest rate. So we know our P, we know our R, we know our I, we just don't know our T, and hence the idea is she wants to know how long it will take. Okay, so we go ahead and punch these things in. We just fill in $200 for the I, because we know that. Okay, equals 450, which is our P. We know our rate, which is 0.065, which is equivalent to 6.5%. And T is our unknown. Okay, and hopefully some of you, or most of you, or all of you, are seeing where this is going. This is going to be something that is hopefully pretty familiar to you. All right, so I go ahead and do my multiplication. I'm multiplying 450 times 0.065, and of course, times T. All right, and what I end up is 29.25 T. Okay, 29.25 T. Okay, and you can, of course, everyone's familiar with this, just like we have been doing for many, many months now. We are going to divide each side by 29.25, or, of course, multiply by the reciprocal of 29.25, because we're trying to isolate that T. And, of course, we do that, and we get T, or time, equals 6.8376 years. Okay, and that's pretty sloppy. okay? One thing to pay attention to is that this interest, the interest is actually paid at the end of each year. Therefore, our time is going to equal 7 years, okay? By 6.8376 years, she will have earned $200 in interest, but that $200 in interest won't be paid until the end of the year, okay? And that happens quite a bit. My wife actually has an account, you know, a retirement account with her work, and they pay them once a year the money that they put into this retirement account. So she may have earned all that money, but they won't put it in until the end of the year. So they save that money in case she quits or something happens. They won't have to pay it out. But anyway, yeah. So T in this case would be 7 years because you would round up from this 6.8376 simply because that interest is paid into that account at the end of each year. Okay, so you won't actually get that interest until the very end of the year. You know, a lot of accounts now, mostly they pay at the end of the month. I mean, some pay at the end of the day, okay? And there's lots of different ways that this works. But when you are earning something called compound interest, for example, and that's something we may talk about this year, I'm not quite sure. You will talk about it next year for sure. We talk about compound interest. You keep earning interest on top of your money constantly. You make some interest, they add that interest to your balance, you make interest on that new balance. So as you can probably predict or understand, you make a lot more money that way. The simple interest, usually paid once a year, okay? You're going to get this much money, and I'm going to pay you at the end. I'm going to put it into your account at the end of the year. These are usually accounts that you are saving with. They're not intended to take out money for groceries or going to the movies, just money to actually use as a savings. Okay. Here we go, exercise 2. We are going to write an equation to find the amount of simple interest, A. Don't know why they're choosing to do this. Maybe you can figure it out for me. But they've just changed our I to an A. Okay, don't let that confuse you. It's just arbitrary. It's just something they're throwing out there. Okay, so we're going to write an equation to find the amount of simple interest, which we're calling A, earned on a $600 investment after 1.5 years if the semi-annual 6-month interest rate is 2%, okay? And that is going to be important to explain, okay? Now we have, again, as we had talked the prior problem, you saw that the interest was paid at the end of each year. In this case, this is exercise 2, they are paying, the bank is going to pay interest out every 6 months, okay? So that money is going to go into that account and be added to the balance, okay? All right. Okay, so again, we can always default to start with our I equals P times R times T equation, all right? But now we have A. A is going to be our new I, okay? So A equals, and again, I don't know why A, but anyway, A equals 600, because we know our investment, that's $600, times 0.02, which is our rate, which is 2%, okay, times, and this is a semi-annual rate, okay, so we're going to multiply this by 1.5, and let's make 1.5 into, all right, well, here we go. I'm asking you a question here. How many 6-month periods are there in 1.5 years? Okay, so this is the thing. So we have a semi-annual interest rate. Okay, so every 6 months, 2% is going to be put into the account. Okay, so before we looked at every year, so it was easy. Okay, how many years are there in 3 years? There are 3. Okay. In this case, we're looking at how many 6-month periods are there in 1.5 years, because every half a year you're going to get paid this much money, all right? And there are 3, right? If we're looking at there are three 3 6-month periods in 1.5 years, okay? 1 year is 2 6-month periods, then another half a year, another 6-month period, so that's 3. And this is why we use 3 here, okay? All right? And again, I know this might seem a little awkward, okay, or maybe hard to understand, but we'll surely have more practice with this. But you have to remember, this really, really depends on when you're going to be paid your interest. Before, the problems we looked at before were all paid yearly, okay? Every year you got paid a certain amount, okay? This time you're going to get paid every 6-month period, so 6 months becomes your whole, okay? It becomes your whole period, all right? Every period you're going to be paid so much money, in this case, 2% interest, all right? So hopefully that seems clear. We'll get some more practice, I'm sure, in the problem sets, and if this throws you, because again, it may very well do so, because this can be quite an issue for some kids. Don't worry about it. Just let me know. Let me know soon, though, so we can really nip all of our issues in the bud, as they say. Okay, and then I go ahead and just do my math. All right, 600 times 0.02 times 3, and that is $36. Okay, so every 6 months, okay, they're going to get paid $12, but we had 3 6-month periods, so they're going to get the accumulated interest is going to be $36 after 1.5 years, because this stands for 3 half-a-year periods. Okay. 3 half-year periods. That's what that 3 stands for. Not 3 years, but 3 half-year periods. Okay, so again, I understand that may be a little bit confusing at this point, but we will have more practice. All right, here we go. We have exercise 3. I'm going to throw something a little bit, even a little bit of a difference here. Throw that at you. All right. We have a $1,500 loan, and it has an annual interest rate of 4 1/4% on the amount borrowed. Okay, and now this is a little bit different because it's not a savings account. It is actually a loan. Okay, this is something you've actually borrowed. When you borrow money, you have to pay a certain amount of interest, okay, on that loan. People don't just loan you money unless they're your family. Well, maybe not your family, but your mom or dad. They'll maybe lend you some money for free, but a bank surely will not. Okay. All right. So we have this $1,500 loan. We have an annual interest rate, okay, of 4 1/4%. This is very, I don't know. I think I've ever seen 1/4% before, but on a loan. But I'm sure it happens. But yeah, make sure you don't get confused there. It's not a half. It's 4 1/4% on the amount borrowed. Okay, we have a couple of pieces of information. Now they want to know how much time has elapsed. So we can tell that we are going to, again, solve for t, okay, because we want to know how much time has elapsed if the interest is now $127.50, okay? That's how much interest has accumulated on this loan, okay? That's how much interest needs to be paid on this loan. That's one thing about getting a loan, and one reason, boy, try really hard and try to do really well in high school and be very diverse in what you do, student council, newspaper, play some sports, and maybe help your mom and dad and get a scholarship, because the last thing you want to try to do is have too many student loans, because you got to pay people for money. You got to pay to borrow money. Anyway, so we want to know how much time has elapsed if the interest is now $127.50. Okay, so we're doing a little detective work here. Again, we start with our I equals P times R times T. Plug in what we know. We know the interest is $127.50. We know our principal, or the loan that we actually took out, was $1,500. we know that the interest rate, actually, boy, if you get a 4.25% interest rate on a student loan, for example, that's pretty darn good, okay? And look at that interest rate. Look at the way it's written, okay? Don't be confused, but you can see that it is 4 1/4%. Do you see that right there? It's where the percent starts, and this 2.5 actually stands for 1/4%, okay? So hopefully you can understand this notation and being able to just immediately put percentages, excuse me, into decimal form. Very, very important. Okay, and then we have our t. T is our variable. It's what we're solving for right now. Okay, and again, like we did before, I'm going to do all the math I can, and that's going to turn out to look like this. $127.50 equals 67.75 t. Okay, so that equals that. Of course, you know what to do. We're going to apply our 63.75. We're going to divide both sides by that same number because it serves as the reciprocal of 63.75 t. All right, and if we do that very conveniently, t equals 2. Okay, so in this case, 2 years have elapsed. All right, 2 years have gone by. So in 2 years, and so I guess we could just figure this out. If that's what we paid in 2 years, okay, that means that we are paying $63.75 per year on this loan. And again, it doesn't necessarily work that way, I have to tell you, because what they do with these loans, and again, I know you don't want me to waste too much time saying this, but this is pretty much the end, I think. We're just going into closing. What they do is they do something called amortization. And what that means is that the banks, the companies who are loaning you this money, they make it so early on when you're paying back your loan, you borrow this money, you go to college, you buy a car, you buy a house. At the beginning, most of what you pay them is interest. That's the extra money, okay? As you move further and further and further into the loan, like years and years later, then you're paying, not until then, are you actually paying more principal, more of that loan back. So, you borrow money, you borrow $50,000, I mean, you're going to pay a lot of money. You probably pay double that by the time you're done with your loan, if you pay it over a long period of time. So again, loans are good. They're very handy. They're, most of us, 99% of us could never buy a home without being able to borrow money. But they can be a very, very, very dangerous thing as well. So it's something you need to know that you are prepared to pay for. Okay? Just a life lesson, and you're only 7th grade, so you're far off. All right, like I promised, we are at lesson summary. We're at 43 minutes, and that makes me happy. Okay, I didn't prepare anything for this one here. So anyway, let's just go over it. Interest earned over time can be represented by a proportional relationship in time between time, in years, and interest. Okay, and our simple interest formula is we know, and hopefully we know it by heart by the end of your problem set and exit ticket. I equals P times R times T. Okay, where I is the interest, R is the percent of the principal that is paid over a period of time, usually per year, okay, and that's your rate, your interest rate. T is your time, okay, in this formula. Okay, so the rate R, the time T must be compatible, okay, and that's the one thing that I wanted to emphasize. They must be compatible. If you have a yearly rate, which they usually are, okay, a yearly rate, you have to make sure your period of time is also in years, okay? So if it's 6 months, okay, it's not going to be a yearly rate times 6, it's going to be a yearly rate times 0.5, okay, which would be a half a year, okay, because that's what this is. This is a half a year, or 0.5 or 5/10 years, okay? And then, let me see, what do I have here? Right here. Okay, if R is the annual interest rate, then T must be written in years. Okay, that's just what I said. All right? So again, let me reiterate though that what we have just been talking about is simple interest, okay? It's very, very simple. It's a good place to start, but like I had said before, it's not entirely realistic. The real world does not normally run on simple interest, okay? But it's just a good place for you to start. All right, I'm going to end it and say good luck on your problem sets and exit ticket, and see you next lesson.